Okay, let's practice solving linear systems of equations by substitution. Remember, we have three options for our solution set. We could either have one solution, some ordered pair, no solution, or infinitely many solutions. Okay, so let's look at our first system. Now, to solve by substitution, we need to have an equation that has a variable completely by itself. Okay, so we need to pick one of our equations here to do that. So I'm personally going to pick that second equation because its y term has a coefficient of 1, and that makes it a little easier for us. So solving that second equation for y, we're going to subtract 3x from both sides. All right, 3x minus 3x is 0, so we're left with y equals, and then we could either write negative 5 minus 3x, or I just like to go for that proper form, negative 3x minus 5. All right, now that we have a variable isolated, we can substitute in the expression negative 3x minus 5 into that first equation for the variable y. All right, so now we have 2x minus 7 times negative 3x minus 5. We're just substituting that right in, equals 12. So now that we're working with one variable, we can solve for x. So we bring down our 2x and we distribute the negative 7. So negative 7 times negative 3x is a positive 21x. Negative 7 times negative 5 is a positive 35. And now we combine like terms on our left-hand side. 2x plus 21x gives us 23x. All right, so now we are going to subtract 35 from both sides. 35 minus 35 is 0. And then 12 minus 35 gives us a negative 23. In our last step, we're going to divide both sides by 23, leaving us with x equals negative 1. Okay, so the x coordinate of our solution is negative 1. We just now need to figure out what is that y coordinate. Well, since we now know what x is, we can substitute in the value negative 1 into either equation for x. Either that first one or that second one. Now you might be thinking you could also put it here. That's exactly right. But we know that this one right here is just that one rearranged, meaning it's equivalent. So we can also use that new one. That's what I'm going to do. So y equals negative 3 times negative 1 minus 5. So negative 3 times negative 1 is a positive 3. 3 minus 5 gives us negative 2. And remember, we can check that solution. It should make both equations true. Okay, let's look at our next example. All right, so I'm going to pick that second equation and isolate that x term because it has that coefficient of 1. So we do that by subtracting 5y from both sides to give us x equals negative 5y plus 3. And then we take that expression negative 5y plus 3, substitute it into the first equation for x. 6 times negative 5y plus 3 minus 2y equals negative 14. Distribute that 6 to both terms. All right, and now we're going to combine like terms. So negative 30y minus 2y gives us a negative 32y. Now we need to subtract 18 from both sides. 18 minus 18 is 0. And then negative 14 minus 18 gives us a negative 32. And now we're going to divide both sides by negative 32. To get y equals 1. Now that we know that our y coordinate is 1, let's figure out our x coordinate. So since we have y equals 1, we can substitute 1 into any equation for y. And we can also use this equation because it is equivalent to that second one we rearranged, and that's what I'm going to do. X equals negative 5 times 1 plus 3. Negative 5 times 1 is -5, plus 3 gives us -2. So our solution is -2, 1.